Hello students, today we are going to start chapter number 13 of class 12, that is about nuclei. Previously we have studied about atoms, all the atomic models, and from Rutherford model it was first shown that at the center of the atom there is a region which consists of the charge and the mass of that atom, and we call that central core region as nuclei. So in this chapter we will study about nuclei, its composition, and other phenomena or reactions that are based on the composition of nucleus and are known as nuclear reactions. So first of all we will start with the nucleus and its constituents, how it is made up of. That's all we are going to study in this video. So first of all, the idea of existence of nucleus, right? So existence of nucleus at the center region of atom was first given by Rutherford in the postulates of Rutherford atomic model. To explain, the reason for this is to explain large angle alpha scattering by thin metal foils. So to explain that large angle alpha scattering that was observed by them during alpha scattering experiment, Rutherford postulate this, that there exists a nucleus in the central region of atom. So there here is the idea of nucleus come into existence. After this, Chadwick discovered neutrons. So discovery of neutrons was done by Chadwick. So after the discovery of neutron by Chadwick, Heisenberg proposed the proton-neutron hypothesis in 1932, which gave us the composition of nucleus. So basically the composition of nucleus is based on proton neutron hypothesis by Heisenberg in 1932. So from this point in the year 1932, when proton neutron hypothesis come into existence, we get the idea of composition of nucleus. Till then we know that yes, there exists a central core region which consists of mass of the atom and charge, positive charge of the atom, but we have no idea what is inside it. So when this theory come into existence, then we get the composition of nucleus, that it consists of proton and neutron. So according to this hypothesis, proton and neutrons are the main constituent particles or building block of the nuclei of all atoms, right? So according to this proton neutron theory, nuclei of all atoms consist of proton and neutron. This is the first point. Now after that, it also suggests that if there is a nucleus of mass number A and atomic number Z, then it will contain Z protons and A minus Z neutrons. So if we have a nucleus with atomic number A, so if we have a nucleus with mass number A, this is mass number, and atomic number Z, this is atomic number. So if we have a nucleus whose atomic number is Z and mass number is A, then number of protons in it is equal to Z and number of neutrons in it will be A minus Z. So number of protons present in the nuclei is equal to the atomic number, and number of neutrons present is equal to the difference between mass number and atomic number. Now the proton give positive charge to the nucleus, however the neutrons are neutral, so the total positive charge on nucleus is equal to plus Ze, because neutrons are neutral, they don't give any charge, and mass of nucleus is because of both protons and neutrons. So mass of nucleus is equal to Z times of mass of proton plus A minus Z time of mass of neutron. So mass of a single proton into Z will give the total mass of protons, and mass of a single neutron into number of neutrons will give the mass of total number of neutrons, and if we add both we get the mass of nucleus. Since we know that atom as a whole is neutral, so to get that concept, it was also suggested that since this nucleus has plus Ze charge, so to balance this charge we need minus Ze charge, which is given by Z electrons revolving around the nucleus in the atom, revolving around the nucleus in the atom. So we can conclude that there are Z number of protons, Z number of electrons, and A minus Z number of neutrons in the atom, out of which nucleus consists of the positive part, that means the Z protons, and A minus Z neutrons. So we can define proton as a fundamental particle. Proton is a fundamental particle which has positive charge of plus E, that means 1.6 into 10 to the power minus 19 coulomb in positive, and its rest mass of proton, which is MP, is given by 1.6726 into 10 to the power minus 27 kgs. This is the mass of proton, and it is about 1836 times of mass of electron. So this is about 1836 times of mass of electron. So this shows that almost all the mass of the atom was because of the protons only, protons and neutrons only. Electrons don't participate much in mass of that atom. They are very lighter in comparison to protons and neutrons. Also, proton has an intrinsic spin, intrinsic angular momentum, which is equal to half. So spin, or we can write it as intrinsic angular momentum of proton is half, and it also possesses a magnetic moment which is much smaller than that of electron. So the magnetic moment of proton is much smaller than that of proton. Similarly, for neutron, if we write all these things, so for neutron it has zero charge, it is neutral, there is no charge on the neutron, and it has mass slightly greater than that of proton. Very small change in the mass exists in comparison to proton. The mass of neutron is equal to 1.6749 into 10 to the power minus 27 kilograms. So if we compare these two, there is a very small change. So these are almost same. Mass of proton and mass of neutron is almost same. It has intrinsic angular momentum also, which is equal to that of proton. Means in case of neutron, the spin or the intrinsic angular momentum is equal to that of in proton. That means it is also equal to half here, right? And say, instead of the fact that it is neutral, it also possesses a small magnetic moment. Although that moment is very small, but it possesses a small magnetic moment in spite of the fact that it is a neutral fundamental particle. So these are the two fundamental particles which are present in the nuclei, and out of these two, this nuclei is made up of. There is one more fact, that since the mass of neutron and proton is almost same, so we can't differentiate them on the basis of mass. So on the basis of mass, we can say that neutron and protons are identical, and the force acting between them, the force acting between neutron and proton, is called nuclear force, which is acting inside the nucleus. Also can't distinguish them. That's why neutrons and protons have a common name, and collectively we call them as nucleons. So if we call nucleon, it means neutrons and protons both. Since they are identical on the basis of mass and on the basis of nuclear force, we can't distinguish them. That's why we give them a common name, that the fundamental particles present in the nucleus, either it is neutron or proton, we call it as nucleon. Now there are certain terms that we use to describe the composition of an atomic nucleus, out of which the first term is nucleons only. So that we have already discussed, that nucleon refers to protons and neutrons both, which are present in the nuclei of atoms, and they collectively known as nucleons. The second term we have is atomic number. Atomic number represented by Z, and it is actually equal to the number of proton present in the nucleus. So the number of proton in the nucleus is called as the atomic number. So Z is equal to number of protons present in the nucleus of that atom. That is called atomic number of that element, and it is denoted by Z. The third term that we use to describe the composition of nucleus is mass number. Now mass number is represented by capital A, and it is actually equal to the total number of nucleons, right? This is equal to the total number of nucleons, or we can also write it as the number of protons along with the number of neutrons. So the number of protons and number of neutrons collectively give us the mass number of that element, and it is denoted by capital A. So for a neutral atom, if we have an atom that is neutral, it will have Z number of proton, Z number of electron, A number of proton plus number of neutron, and A minus Z number of neutrons, and we represent this number of neutron by capital N also. So capital N is equal to number of neutrons, which is equal to the difference between mass number and atomic number, that is A minus Z. Now let's see the next term, that is nuclear mass. Nuclear mass, don't confuse between the mass number and nuclear mass. Mass number is actually the number of those particles which are participating in the mass of that nucleus. So that's why we call it as mass number, because proton and neutrons are the particles which provide mass to that nucleus. So mass number is the number of proton plus number of neutron. It is not any kind of mass, it is just a number. But if we are talking about nuclear mass, then nuclear mass is the total mass of protons and neutrons present in a nucleus. That is called nuclear mass. So nuclear mass is basically equal to the total mass of nucleons in a nucleus, or we can also write it as mass of all protons plus mass of all neutrons. This is equal to the nuclear mass of that nucleus. The next term that we use generally is nuclide. So nuclide is a term which we use when we talk about an atom with reference to its nuclear composition. Means if we talk about an atom with reference to its atomic number, mass number, that is its nuclear composition, then we use the term nuclide. So we call or define nuclide as a specific nucleus, of an atom characterized by its atomic number, that is Z, and mass number, that is A. So atomic number Z and mass number A, it is symbolically represented as X, and in the bottom we write Z, that is atomic number, and at the top we write mass number X with atomic number Z and mass number A. For example, if I talk about hydrogen, so for hydrogen it is 1H1, right? 1H1. Similarly, for chlorine it is 17Cl35, so etc. Okay, and so on. We can write it for any element. So that specific atom, when we talk about it in reference to its nuclear composition, then we call it as nuclide. So these are the terms that we generally use to describe a nucleus in our regular purpose. So that's all about the introduction or the composition of the nucleus. Now after this we will study much more about nucleus and what is happening because of this nucleus, what reactions are going on. That's we all study further. For that, stay tuned and keep studying. Thank you.